All right, so in section 2, we're going to be dealing with some hypothesis testing, so I thought we'd look at a couple problems. See how StatCrunch can help us find some of the values. Some of the things we have to determine from the reading. So when I'm looking at this, it says test the hypothesis using the p-value approach. This is the one that I prefer and I'm probably going to test you on. I am not a big fan of the classical approach. I like the p-value approach. Be sure to verify the requirements of the test. So here's our verification. Is m times p times 1 minus p greater than or equal to 10? So when we do that, we could just bring up our calculator to help us do that. So it's n times p times 1 minus p. That has to be greater than or equal to 10. That helps us determine if the distribution is somewhat normal. So we have 500 times 0.85, then times 1 minus 0.85, which is 0.15. And we see that it is greater than 10, so we say yes. Next, we're going to go to, let's find the p-value. So when I do this, I'm going to go to StatCrunch. Let's see what they're asking us. We know that n is 500, x is 410. Our null hypothesis is that our proportion is 0.85. Our alternative hypothesis is our p is not equal to 0.85. So we have a two-tail here. So let's see how much of that I will remember. So I'm doing a proportion stats, one sample with summary. So this is very similar when we made confidence intervals. I believe we said 410 out of 500. So that's the sample that we collected. Our null hypothesis is we believed it was 0.85, and our alternative is that it was not 0.85. Let's verify this real quick. 410, 500. And again, notice our alpha is 0.01. It's kind of like our level of significance that we had before when we were looking at our confidence interval, how confident we are. So our level of significance is kind of like a measure. When we compute this, we are going to get a p-value. If our p-value is less than our alpha, which is 0.01, right? Our alpha is 0.01. If our p-value is less than alpha, then that's when we would reject. That just means it's unlikely if it's lower than our alpha. Ours is actually higher than our alpha, 0.0603. So 0.060 to 3 decimal places. We're next going to reject or fail to reject. So I'm not going to reject because my p-value is greater than my alpha. So there's a saying, if the p is low, the hoe gotta go. So our p is not lower than our alpha. So we do not reject the null hypothesis because the p-value is greater than our alpha. So you can quote me on that one. If the p is low, the hoe gotta go. So what we've just said here is that based off of our sample that we took, 410 out of 500, that gave us a, see if I can get back to my StatCrunch. That gave us a sample proportion of 0.82, which is not 0.85, but it's close enough to 0.85 for us to say we still think the proportion is 0.85. So that's what we're kind of saying. Another one to look at is number 10. So previously, 37% of parents of children in high school felt it was a serious problem that high school students were not being taught enough math and science. So 37% of parents thought it was a serious problem. A recent survey found that 84 out of 200 parents of children thought it was a serious problem. Do parents do they feel different today? So this is what it was in the past, 37%. And now it's whatever this proportion is, 84 out of 200. So is that different enough to 37% to say that we think that parents feel differently? Now, it doesn't mean your null hypothesis is always going to be equal what they tell you. So that's something that's given. You should have dove into that in section 1. This one says, is it going to be greater than, less than, or not equal to? It'll never be equal to with what we're doing. Our alternative hypothesis, it'll either be greater than, less than, or not equal to. We have to determine that by the context of what they say here. Do parents feel differently today? So that doesn't say greater than or less than. That says not equal to. That's what different stands for. Is it different than 0.37? So these numbers, whatever you put in this, will also go here. This is what was believed in the past, 37%. And this will always be equals. This is the thing that's going to change. Is it greater than, less than, or not equal to that value, the 0.37? Now we need to find a p-value, so I'm going to go back to StatCrunch, and it'll help me do that. So I'm dealing with proportion stats. So proportion stats, one sample with summary. I think it was 84 out of 200. I'll verify that in a second. And I remember the 0.37, and we said it would be not equal to 0.37. So let's verify 84 out of 200. Our alpha is 0.05 this time. So let's compute. So we got a sample proportion of 42%. So that's different than 37%, but is it different enough to say that we think things have changed? I have a p-value of here of 0.143. So I believe that's what it's asking next, 0.143, which again is greater than my alpha. My alpha on this one was 5%. So if my p-value was lower, I would be rejecting. But my p-value is not lower than my alpha, so I will fail to reject. So, yes, there is sufficient evidence, meaning that we do not reject the null hypothesis. And so we are not going to reject. So no, there is not sufficient evidence, meaning that we do not reject the null hypothesis. So that's the one that we're looking. There's not sufficient evidence for us to reject the null hypothesis. We still think the real feeling for parents is 37%. Yes, the one sample that we did was higher, but that's not high enough for us to say it's not 37%. So if this value was lower, we would have to reject, but is not lower than my alpha.